So now see, as we were discussing the 2023 makeup exam, we have done mesh analysis question. Now next question is of 4 marks, that is based on maximum power transfer theorem. So in this basically we need to calculate VAB, right? As I told you, always mark the point, like suppose this is C and this is D. So can we say that VAB must be equal to VAC plus VCD plus VDB, right? You are moving from A to C, so current would also move from A to C, I1. You are moving from C to D, so current must also move from C to D, I2. And you are moving D to B, so current must also move from D to B, that is I3. Okay, in whichever direction you are moving, you have to take the same direction. Now let's mark according to this sign, according to the direction. Now I told you we have to take the second sign, right? Every time we need to take the second sign, so it would be minus 15 I1 minus 20 I2 minus 27 I, correct? So in this, for calculation of I1, I2, I3, we need to apply mesh analysis to this circuit. Then we'll be able to get the I value for I1, I2 and I3. Now can you tell me how many meshes are there in this particular circuit? Now
Ma'am,
see, we'll have 3 mesh. In this, he has taken actually first sign. That's right. You can take first or second. That's okay. So after
okay.
solving I1, I2 and I3, you'll get the values and you can substitute it here, then you'll get VTH, right? So do it, complete this in your homework. Now in the next part we need to calculate RTH. Okay, so for RTH what we need to do, voltage source must be removed and make it short circuit, and current source must be removed and make it open circuit. So if I'll redraw the diagram, resistance must be as it is, RL must be again open circuit. So the diagram looks like this, yes or no?
Yeah.
So just imagine that you are standing at A, you need to move towards B, correct? You need to move towards B, and then in that case you are, this is your home. Always imagine like a normal way, like A is your home and B is your college, maybe hostel to college, hostel laga lo, hostel to college. You need to move from hostel to college and you are getting late for the first lecture. Okay, generally you people are getting late now for the first lecture. So all these are your resistances, are your friends. Okay, now tell me, if you'll move it like this, 5 ohm and 10 ohm, they are at the same path or at the different path? This 5
Yes.
same path, so we can combine it, and we can combine it into a single resistance, that would be how much? 15 ohm. Okay, now in this, no resistance is same, like, because here wire is there now. So this wire is connected between C point. Let us consider the D point. Okay. Now as you can see that this is A, this is, it looks like delta. Yes or no? This is, let
Yeah.
us consider A, C and so it looks like delta. If I'll redraw this diagram like this. So can we convert delta into star? Yes or no?
Yeah.
Okay. So looks like star. I'm reading 20 as इसको अभी मैंने टच नहीं करा, will remain as it is 9 7 1, and you can see 18 and 9 is also series, so convert it into series, then it will make again 27, and again it looks like delta, right? So we can convert. delta 2 star, right? We can
Yes,
convert delta 2 star. Now I'm redrawing this diagram again. So this is A, this is B. See this. After solving, we'll get this value. Solve it further. Okay, after this, as you can see, this 5, 20, and this 9. They are in series, right? So it will become a single resistance. Then
yes,
after
ma'am.
that, now see this resistance and this resistance is in series. They are connected through the same path, right? So it will become like this. Now this yellow one and blue one will become parallel with each other and then combined it. This is 5, then you will get some value. This is 5, 9, so 5 plus 9 is 14. This is 25 plus 9 is 30. So 34 and 14 is in parallel, then all 5 and this one resistance will be in series. So that would be your RTH. Correct? Hmm? So in this particular case, we can get the value for RTH after solving. We need to calculate maximum power. So you can simply substitute maximum power is equal to V square TH by 4 RL, and RL is equal to RTH. Correct? Yeah.
Yes,
Now
ma'am.
the next question, that is simply the superposition, and I think this question is also written in earlier papers, but this is in makeup exam. If you know the concept, then you will be able to. Do you know what we'll do in the superposition? We'll take one source at a time and remove another source. So in the first step, we'll take first source. First source is 40 volt, the diagram, and then remove another source. Another source is current source. Current source must be open circuit. At a single step, there will be a single source, the circuit. ठीक है, एक step में एक ही source रहेगा. So now they have asked you to calculate current in I dash. So mark I over here, then it will be I dash. Now in the second step, we have to take the second source now and kill all other sources. So killing voltage source means that must short circuit it, and we have to take this source 8 ampere. Correct? So 12, 5, 4. Now we need to calculate over here I double dash. So that's up to you totally. If you want to do it for mesh, then go it for mesh. If you want to do it by nodal, then go for nodal. So I would be equal to I dash plus I double. Okay. So we see it's a RLC. I told you come from. So generally I told you about the DC. In AC circuit, one question you will get it from parallel. Third question get it from power factor. Okay, maybe they'll give you the fourth question base, and one question get it like this waveform kind of. Yeah, five questions, four questions or three. Now back to this series RLC circuit. In this they said low diagram that would but they said ki power kilovolt and 0.8 power factor lagging means cos phi is 0 point. Now
Ma'am,
voltage,
when they give, like, how do you identify if it's active, reactive, or a parent power?
if it is according to the unit now, kilowatt. What is the unit of
Okay, yeah,
active power? R is the unit of reactive power, and VA is the unit of.
yeah,
Okay. So according to power, active power formula, VI cos phi 1 2 kilowatt means 2000 volt. Voltage is 240. Current cos phi is 1.8. So we'll be able to get the current. Okay. Next is we need to calculate power factor angle means they are phi. Cos phi is 0.8. Phi is cos inverse. Next they are asking impedance, resistance and reactance means whatever it is. So V is equal to I into Z, correct? Voltage is 240. Current is we can get it from here, and angle is phi. Okay. Can you convert it into the rectangular form? First calculate the value for current, and so after solving we'll get Z is how 40 by 10.41, the 10 randomly I'm, then that would be 24. Okay. So Z will be how much? 24 and 0.8 polar. So to get the value of R and L, we need to convert to rectangle. Okay. How will you convert this polar to rectangular form? By using calculator. Take out your calculator, press shift button, then minus. Above the minus you will see tick is there. In whichever form we want to convert, we need to write that. We want to convert it in rectangular form, and which number, that is 24 and 36. So in bracket write down 24 comma 36 point. Tell me what you will get it in the rectangular form after conversion. Now see, if you'll compare it, then this is R plus J, right? Z is equal to R plus L. If you'll compare this, then you will get R is equal to and X equal to point, and XL is equal to by FL. XL you know, F you know, you can for recipe, but they have asked reactance only. Reactance means X. But if they have asked you
ma'am.
inductor,
How do
then
you
you
know?
can do it. How
How do
do
you know
I
it's an
know that
inductive?
it's a reactance? If there is a combination of R and XL, if there is a combination of R and C, then Z is equal to R minus. So if you'll get the plus sign, that means it is XL. If you'll get the negative sign, then that means that will be okay.
But ma'am, what if it's I?
If they said it's a power factor is leading, then in that case the load must be capacitive in nature, combination of R and C. If they said lagging, then in that case it's a inductive in nature, means maybe the combination of RL. Okay. So accordingly our answer is also correct because we are plus sign, so that would be LL means inductor, and it's okay.
Okay, ma'am.
How can we get this question? Total admittance means total impedance ZT. Just consider, right? So Z1 is how much and Z2 is how much? 6 minus how much? Z1 in by Z1 plus Z2. In the polar form we can do multiplication. So 6 plus J8 divided by this plus J. So for this we need to convert into polar form, right? Now ZT is 1 by Y. So next is both conductance. Conductance is G1. 1 is equal to 1 by Z1 equal to 1 by Z. Acceptance abhi. Then we'll have total current. Total current would be total voltage divided. Total voltage is 200. If angle they didn't mention, then consider total impedance you have, right? So power factor is what? Cos phi. As I told you always, ki power factor R by. But this is the case of parallel. So how can we calculate power factor cos phi? We need to calculate phi. Phi is what? The angle between voltage and current. Or we can say phi is the angle of impedance. Calculated impedance over here, right? So whatever the angle of impedance you will get, that would be phi. Then tell me, any doubt up to here? Hence is by, and its formula similarly hence is denoted by, and its hence that is what. If you want to calculate total admittance, one is 1 by Z1, फिर ऐसे भी कंडक्टेंस निकाल के स्क्वायर ऐसे निकाल के स्क्वायर the root. Okay, unit for conductance this and this. Cause resistance, inductive reactance, impedance की unit क्या होती है? Ohms. And opposite of ohm is mho. Remember? And mho is equal to, got it? Now, third part of the, in the third part, this question of power factor, the value of pure capacitance to be parallel. With this, they have connected pure capacitance with the above combination to make the total power factor. Remember, I told you that the power factor improvement question have to make power triangle, right? So basically they have combined two parts. So parallel वाला भी कर दिया और power factor वाला भी. As I told you starting at questions of AC circuit आया था ना मैंने, that C question आ गया, parallel power factor they combined it. Okay, now see how can we do the question based on power factor improve. One is without improvement, one is with improve. And here you need to calculate in the power triangle, here is P S, so P1 Q1 S1, similarly S2. Okay. Without improvement means where power factor is 0.5 होगा या 0.6 होगा, कुछ भी होगा, that must be less. And with improvement obviously the power factor improves near to unity. यहाँ पे क्या दिया कि it's unity only, unity means 1. So in this case power is always given, okay, maybe directly or maybe indirectly, and P1 is always equal to, ठीक है, जितनी पावर यहाँ होगी उतनी पावर यहाँ होगी. Cos phi they must have given. Cos phi का formula is P1 by S1. So already know cos phi, that is given in the question. From here you can get S, right? With the help of S1 you can get Q1 by the formula S square is equal to P square plus, correct? Then after that P1 is equal to P2, P2, and again cos phi is given. Again we'll use formula cos phi is by cos phi given P1 get get Q, right? Ultimately, we'll need Q2 and Q1 only. Q2 minus Q1 is equal to nu is equal to V square. The voltage, these are the terms given. From here, you can get XC, and with the help of C. This is the method I told you. Every question may for power factor improvement that 100% I can guarantee that this will come. So you have to do the same procedure in each and every question. First of all, write down this procedure in formula sheet. From here, power factor cos phi. I'm considering random cos phi. This would be cos phi is 0.6. Now we need P. Formula is how much? Equal to I cos. Voltage, current, you calculate. Cos phi also. From here you get P. I'm again considering the random. Let us consider 2 guys solve kar. So here P1 is 2 kilowatt. If you know P1, if you know cos phi, you will get S1, you will get S2, right? Sorry, Q1. Then after that P1 is 2 kilowatt, then P2 also 2 kilowatt. I told you that it would be right. So, and this said in the question, power factor for the new case is unity. Unity means cos phi must be equal to 1. So in this case, cos phi is equal to 1, then E must be equal to S only, right? So this is also 2 kilowatt, must be 0. You can substitute 2, or you can 1 minus Q1, you will get it. Q2 is 0. You already know the voltage, V voltage 220 volt, 100 volts, and you will get XC, and XC formula is XC is equal to 1 by 2 pi FC. Okay. Next question is based on resonance, 3 marks. What is resonance based? In the resonance, we'll have one condition. What is that? That is XL must XC. Means inductive reactance must be equal to capacitive reactance. If XL must be equal to XC, then in that case Z must be equal to R only, right? Because Z का क्या फॉर्मूला होता है? Z is equal to root of R square plus XL minus XC का whole square. तो ये equal है तो Z is R. And if Z is equal to R, then in that case, so XL, if I'll solve this, XL is equal to XC. XC का formula is 2 pi FRL. Normal frequency से resonant frequency is different. ठीक है? So if I'll calculate from here, FR would be equal to 1 by 2 pi root LC. ठीक है? This is resonant frequency. Next, in this we need to calculate quality factor. तो quality factor का formula is 1 by R root L by C, या फिर quality factor को QF से भी denote करते हैं. उसका फॉर्मूला होता है XL by R. XL is how much? Again 2 pi FRL, resonant frequency. यहाँ पे FR की ये वाली वैल्यू डालोगे, then you will get the same thing. Next, we'll have another formula for quality factor, that is resonant frequency divided by the bandwidth. And what is bandwidth? Bandwidth is the difference in the two frequencies. So bandwidth का एक और formula होता है, that is omega 2 minus omega 1. Omega 2 is the upper half frequency and omega 1 is the lower half frequency. Okay, we'll have another formula, omega 2 into omega 1 is equal to 1 by LC, and omega 2 minus omega 1, this is bandwidth only, that is R by L also. This is R by L. Now what is omega 1 formula? That is minus R by 2L plus root of R by 2L ka whole square plus 1 by LC. I think this formula in book you need to check. Minus R by 2L, this is also L, minus root of R by 2L ka whole square plus 1 by LC. ठीक है? all formulas covered in single page.
into the formula, right? That's all.
So this is the case of resistance. FR is equal to 1 by 2 pi root, right? Bandwidth, how much R by, and L. Next is lower half and upper half frequency, means omega 1 and omega. You just need to substitute the value. It just took me hardly 5 minutes, right?
So like from the triangle we can get
See, in this case, they said a single phase motor means load. It takes a 15 ampere current. Okay, supply is given, that is 30 volt, comma 50 hertz. Now they said power factor is 0.6, so cos phi for this case must be 0.6. Determine the capacitance of the capacitor and the current taken by it connected in parallel with it to correct the power factor to 0.8. As I told you, na, it is the case of power factor improvement. So this is first case without improvement. After improvement, cos phi will become 0.8, and they just ask you that how much capacitor we need to add it to improve the power factor from 0.6 to 0.8. So again, draw two triangle, right? This is P1. P1 is how much? Vi cos phi, P 230, current 15, cos phi 0.6, right? You can get P1. P1 and P2 is same. For this case, cos phi is 0.6. You can get S1 by the formula cos phi is equal to P1 by S1. So you will get Q1 as well. Similarly, P1, so cos phi is equal to 2 by S2. 2 and P1 is same. P1 is equal to P2. So cos phi also that is 0.8. S2 Q2 then again you will do Q1 minus Q2 is equal to Q new, that is equal to V square by XC. So from this Q1 Q2 voltage you can get XC, from XC you can get C by the formula 1 by 2 pi F. Okay, now they're asking the value of supply current after power factor correction. So इस case में new case में they are asking the current, so again you can get it P equal to VI cos phi वाले formula से. In this case cos phi is 0.8, power तो P2 वाली हो जाएगी, voltage is same, you can get the current. Easy or not? Question is 3 phases of complete 6 marks. This is all the load are different, so this is unbalanced. First thing, in unbalanced it is delta, and in the line voltage must be a phase voltage and current would, right? So I told you R IR Y R RYB is na. This formula is given in your handbook also. So IY is how much? IRY IB R. Okay, okay. So now as I have given voltage, L is equal to, as I told you, every time they'll give you the line 50 hertz. Now you need to calculate current RY according to Ohm's law. H is equal to H into ZP, correct? So let us consider first VRY is equal to RY. VRY is 415, first angle degree, I 2 degree. VRY magnitude is same, 450 is 415, 120, R is 400, correct? So IRY you need to calculate Z 50 plus. Similarly, VYB is equal to IYB by, right? YB is how much? 400 120 degree. IYB you calculate, ZYB is 1. Similarly, VR is equal to IBR R. So VBR is how plus 1 degree. IBR 3 minus, okay? IRY, IYB and IBR, IR. They ask you to phasor sum, तो इन तीनों को ऐड कर simply add it. Okay, now see they said the star connected balance load 6. The load is connected to this voltage 8 volt L 2 wattmeter thing. So IZ है, Z पता है, we can get I ना, and V पता है, Z पता है, we cos phi by Z 8, Z is 8 plus square plus 6, right? Sorry. Find the readings of the wattmeter. W1 is how much? VL IL cos of 30 minus plus 5. तो VL पता है, IL भी यहाँ से पता लग जाएगा, IP type. This is start, so you need to convert it. That would be VL by √3. Phi पता है, phi कहाँ से? यहाँ से. Similarly, you will get W2 VL IL cos of 30 minus 5. Okay, तो एक्टिव पावर, रिएक्टिव पावर, रैपिड पावर ये भी पता लग जाएगा. P equal to L IL cos phi. But basically when you need to calculate IL and phi. IL you will get it from here in the stars. IL is equal to IPH and phi you will get it from here. Done.